Good morning, students. After completing the atoms topic, Rutherford's model, Bohr's theory, the different things, its limitations and all, with that we have completed the atoms. After atoms, now we are to discuss or we are to start our discussion with the nuclei. Nuclei. Obviously, regarding the nuclei or nucleus, we have a small idea from Rutherford's alpha scattering experiment, which was performed in the year 1911, as we have mentioned it also. But mind this, that was nucleus, regarding the nuclear size and all we have discussed, but that was mainly for the gold nucleus, exclusively for the gold nucleus. Now we are wanting to discuss regarding the nuclei of general normal atoms, the different atoms that we are going to discuss. First of all, before we start, in the starting, we are to discuss the composition of a nucleus. Let us discuss the composition. A nucleus is considered to be spherical in shape. In this, actually we are showing it in this way. It is considered to be spherical in shape and in this way. Actually, we are showing it in this way because it does not have a sharp boundary like the atoms and all. Right? Like the solids, it does not have a sharp boundary. So it is considered like this. It is consisting of neutrons and protons. Neutrons and protons, if we talk about their masses, mass of a proton, I just tell you, nearly 1.6725 into 10 to the power minus 27 kg, whereas mass of a neutron 1.6749 into 10 to the power minus 27 kg. You can very easily understand that neutron and protons are almost identical particles if we consider them according to their masses, right? Obviously, proton is a positively charged particle, neutron is an uncharged particle, okay, but a term we shall discuss, a term nuclear force, that is a force which exists inside the nucleus, that does not distinguish this neutrons and protons, because in between neutrons and protons, in between protons and protons, in between neutrons and neutrons, everywhere the nuclear force is the same. So it does not distinguish. So almost these two are considered as the identical particles, right? Obviously, regarding the charge, as far as the charge is concerned, the proton has the positive charge, as I mentioned, and neutron has no charge. Okay. Now, here, there are certain terms like nucleons. Neutrons and protons together are known as the nucleons. Neutrons and protons, they are considered collectively, they are known as the nucleons, right? And total number of nucleons, that is called the mass number, whereas total number of protons is known as atomic number. Mass number is represented by capital A, atomic number is represented by capital Z. There is a term called nuclei. Actually, nuclei, you can write down nuclei. Nuclei is a specific nucleus of an atom. Specific nucleus of an atom. It is indicating the specific nucleus of an atom characterized by its atomic number and its mass number. Characterized by its atomic number and its mass number. Okay. Characterized by its atomic number and its mass number means, suppose any atom or an element X, its nuclei will be represented by X, A, Z, like this. Obviously here A minus Z, it is the number of neutrons, right? It is the number of neutrons. A minus Z is called the number of neutrons. These are very fundamental things I am discussing. In this context, I want to discuss a term I think you must be knowing. It is the atomic mass unit, AMU. What is this? It is 1 by 12 of mass of C12-6 atom. C12-6 atom is nuclei, 1 by 12 part. So it is equal to 1.67 into 10 to the power minus 27 kg. Very important. I hope all of you know one atomic mass unit is this value. Now, if I use here Einstein's mass energy equivalence, all of us know that E is equal to m into c square. M into c square. I want to do a calculation here. This is E is equal to mc square. Mass is this. I will find out a corresponding energy. Right. So, corresponding energy for one atomic mass unit, that is equal to m into c square. In place of m, I will write 1.67 into 10 to the power minus 27. C square, in place of c square, I will write 3 into 10 to the power 8 whole square, because c is the, you know here, c is the speed of light. Obviously, c is known as the speed of light. So 1.67 into 10 to the power minus 27 into 3 into 10 to the power 8 whole square. This much, but this much, what we are getting? This much joule. Okay? I hope all of you know, we have discussed 1.6. I am writing here in this way. Now, 1 electron volt is equal to 1.6 into 10 to the power minus 19 joule. All of you must be remembering 1 electron volt. The value of 1 electron volt is this. So 1 MeV, it is the mega electron volt, that is 10 to the power 6 electron volt. 1.6 into 10 to the power minus 13 joule. I hope you must be knowing. If you don't know, just understand it. So E is equal to 1.67 10 to the power minus 27 into 9 into 10 to the power 16 divided by 1.6 into 10 to the power minus 13. and it comes out to be nearly 931.5 MeV. Hence 1 atomic mass unit is equal to 931.5 MeV. Look, this we are getting. 1 atomic mass unit is equal to 931.5 MeV. That's a very important point, and this it will be very helpful in solving the numericals. Sometimes it is given in the questions, sometimes it may not be given in the question, sometimes it may be given in the question that 1 atomic mass unit is equal to 931 MeV only. So using that data, you can solve the questions. So this is regarding 1 atomic mass unit, this value. Very clear? I think to all of you it is very clear. So this is a very useful conversion. 1 atomic mass unit is equal to 931.5 MeV. Okay, fine. Now we are coming to, in the next lecture I am coming to the size of a nucleus.